Hello, in this session I'm going to look at binomial CDF using a Casio calculator. One of the things that we will be doing is probability when we ask for at least X number of successes. So I'll put here X, just the screen is just blacked out. Wait for a second, it should come back on again. I hope. Gotta have faith when the screen goes blank. Probability of X successes in an N trials. Now the calculator has an interactive, so I'm going to go to the calculator, warm up your calculator, do this in your calculator, go to interactive, distribution, discrete, binomial. Now you should get 4 windows on your calculator: lower, upper, num trial, and the chance of POS, which is the probability of success, POS. Now, if we want to have, say, 12 games of tennis, so here we know we're playing 12 games of tennis, and the chance of success is 70% of winning. That means we've got a 30% chance of losing. So that's a 0.7% chance of probability of success is 0.7. Our number of trials here is 12. And what we're going to be doing is probability of getting at least X. I'm just going to, I don't know if my computer is sharing again. So let me just put this information in the calculator and share this probability of at least, and I said at least X successes. Oh, there it goes, successes in N trials. Come on, computer. All right, so let's say we want the probability of getting at least 10 successes in those 12 games. So we want the probability of winning 10, 11, or 12. Well, let's just find the probability of winning only 10. So let's put lower 10, upper 10, the number of trials 12, and the probability of success 0.7. Okay, now that tells us that we're going to have a 16.8% chance of winning 10 games, 16.8. Let's find out the probability of winning 11 games. So interactive, distributed, discrete, binomial. Okay, this time the lower is 11 and the upper is 11 because I want exactly 11. The number of trials is 12 and the probability of success is 0.7. All right, well, we've got a 7.1% chance of winning exactly 11 games. Now that's, if you remember 16.8, let's, on the calculator, I'm just going to add these up as I go. 0.16779 plus 0.07118 plus. Now, what's the probability of winning exactly 12 games? I'll try one more time with this computer, see if we can present the whiteboard. I'm having trouble, but you have to use your calculator in this activity anyway, so you have to listen to my instructions if you can't see my whiteboard. Probability of X successes in N trials. Now here I'm using an N as 12. Here I'm just using at least 10. This means X is greater than or equal to 10. All right, so I've just worked out the probability of 10 is 0.168. Then I've done the probability of exactly 11 is 0.0711. Now I'm going to do the probability of exactly 12. Interactive, distribution, discrete, probability. Lower is 12, upper is 12. That's exactly 12 out of 12 trials. And chance of winning one game is 0.7. And we're going to have chance of winning all games is 1.4%. I'm going to add that in with my other two numbers, 0.01384. Now, the sum total of those three probabilities is about 25.3%. So it's about 25.3%. Let's go back to interactive, distribution, discrete, binomial CDF. I'll put that here. This is an incredibly important command. You will see the command each time you go to the screen. So the lower limit is 10. The upper limit is 12. So now I'm going to go from 10 all the way up to 12. The number of trials is 12. The probability of success is 0.7. Here you get 0.252815. There you have the answer, 25.3. That is the probability of at least 10. What I want you to do is pay attention to the screen. Have a look at the command that you see on the screen. Do you see the command binomial, capital C, capital D, little f? Binomial CDF. Now in brackets, you've got 4 numbers. The first number is your lower limit. The second number is your upper limit. The third number is your number of trials, 12. And the fourth number is your probability of success is 0.7. Now, this is the critical command that I'm focusing on this particular session. In that example, we knew P is 0.7. We also know Q is 0.3. So I'm just going to write this down. Well, if it lets me. Binomial, capital C, capital D, little f. Now, we've got a 10, minimum, upper limit 12, number of trials 12, and probability of P is 0.7. Now, if you can't see that, I'm just going to, sometimes when my computer goes on the blink, I have to reshare my screen. That's okay. That's technology at the moment. My computer is misbehaving. This is an important command. Binomial, capital C. You can type that straight into your menu, or you could use it through the interactive. Now, in this example, we knew P was 0.7. We knew Q is 0.3. And we know N is 12. Okay, and the computer's gone on the blink again. What I want to do now is, okay, there's a 25% chance of winning at least 10 games. Well, if I was to be 95% confident of winning at least how many games? I'm 25% confident I'm going to win 10 or more games. But if I want to call my mum and say, Mum, I'm about to play 12 games, I am 95% confident I will win at least, what number will I put now? Now we know the answer is going to be 0.95. All right, one way we could do that is to keep changing 10. All right, let's just change 10 down to 9 and rerun that. Now we've got at least 9. We've got a 49.2% chance of winning at least 9. Now let's change the lower limit to 8. The upper limit stays as 12. Now we've got a 72.3% chance of winning at least 8. Let's change that number down to 7. I hope you're doing this activity with me. So binomial CDF, 4 numbers are 7, 12, 0.7. All right, my computer's coming back on again. I'm not sure if you can see this. I have to keep sharing my screen because before I share it, I'm going to, maybe it's because I'm sharing it using Google Meet. So I'm going to fill this in. I'm going to change my formula, binomial, capital C, capital D, little f, down to 7. Now, 7, it's still, this is the probability of at least 7. So x is greater than or equal to 7. And I get 0.882. Oh, no, it's not Google Meet because it's going on the blink again. All right, so when that comes on, I'll share that. I'm going to change that 7 down to 6. All right. Now we've got a 96.1. Yes, now we're confident at 96%, which is more than 95. So my boundary line was 95%. So I will say I am 95% confident. In fact, I'm 96% confident. But at the 95% mark, I can call mum and say, I should win. I'm 95% confident I will win at least 6 games. I will win at least half of my games out of 12, which is pretty good. But, you know, you've got a chance of winning 70%. You'd think you'd win 70% or more. But yes, 0.7, remember NP and NPQ? Okay. The standard deviation and the mean. The mean is NP. Now, 12 times 0.7, 12 times 0.7 gives 8 games. Now, we wanted to be 95% confident. You see, there is a 95% confidence of 2 standard deviations above and 2 standard deviations below. I could find the standard deviation of this, the square root of NPQ. So the square root, my computer hasn't come back on again, the square root of 12 times 0.7 times 0.3. Okay, that is 1.6. Now, if I go 8.4, down 2 standard deviations, so down 2 lots of 1.6, that takes me to 5.2 games. Now, if I go to 8.4, which was my average, my mean value, NP, plus 2 standard deviations, plus 2 times